Let's continue by diving into our topic of proportions. If we knew a ratio and we want to apply that ratio to a different scenario, like we did with the red marbles, we can use proportions to set up equivalent ratios and calculate unknown quantities. A cookie recipe calls for 1 cup of sugar, 3 cups of flour. If we use 9 cups of flour, how much sugar do we need? The ratio of sugar to flour must be 1 to 3 in order to match the recipe. The ratio of sugar to flour in our batch can be written as x to 9 since we don't know how much sugar we need, but we do know how much flour we're going to use. So we can write a proportion. And we can start with 1 to 3, but write it as a fraction rather than using the colon. 1 cup of sugar, 1 cup of sugar compared to 3 cups of flour. And we need to set that equal to the unknown cups of sugar, again to the 9 cups of flour that we will be using. And so we can look at this as equivalent fractions. 1 over 3 has to equal x over 9. And there's a couple different ways that we can evaluate it. We can look and see if there's an easy multiplicative relationship from denominator to denominator or numerator to numerator. And since we do have one where we could multiply by 3, we can do the same thing to our numerator in order to solve for x. 1 times 3 equals 3. So x has to be 3. 3 cups sugar. The other way to do this is by using the quantity of least common denominators and least common multiples in order to essentially cancel out the denominator. So we can multiply both sides of our equation by the least common denominator. In this case is 9, since 9 is a multiple of 3. So when we have 9 times 1 over 3 equals 9x over 9, we can simplify each of these fractions, reducing it to be 3 equals x. Okay? Now this is a more complex way when we have such a simple fraction comparison here, but the idea holds true even if we can't find a nice easy multiplicative relationship from one fraction to the other. Sometimes we'll have decimal values, and this is the process we would use to solve. Now, there are multiple ways to set up a proportion. In order for it to work, the most important thing is that the same units need to either be on the same side of the equation or the same side of the divisor line. We should be able to draw a straight horizontal or vertical line from one unit to the next in order for the inequality to work. But if we see that our units cross diagonally from each other, that is not going to be a proportionate, an equal proportion, and we will not be able to use it to solve. So let's go ahead and use a couple examples and proportions to solve these examples. There are 340 students at Dubois Academy. If the student to teacher ratio is 17 to 2, how many teachers are there? So we have to look at the ratio where we are comparing the students to teachers. Okay, we're given the ratio of students to teachers, and we want to solve for the number of teachers. Generally, the easiest thing to do when solving is set the unknown quantity on the top. Since we're solving for teachers, let's write it as a teacher to student ratio. It makes solving significantly easier if we do a teacher to student ratio, the unknown quantity on the top. And so we can start with the ratio that was given. There are 2 teachers to 17 students. We want to solve for the number of teachers, and there's 340 students. Okay, so now what we can do is multiply by our least common denominator. And our least common denominator here is actually going to be 340 because 340 is a multiple of 17. So we multiply both sides by 340. And when we simplify, we find that we get 20 times 2 equals x. 340 divided by 17 simplifies to 20. We multiply it by 2, and we get x. So there are 40 teachers at the school. Next one, we've got a local zoo houses 13 penguins for every lion that it houses. The zoo houses 78 penguins. How many lions and penguins are there in total? Okay, so they give us one ratio, but now they're asking for a different relationship. So let's start with the 13 penguins to every one lion. Well, this is a part-to-part relationship, but they're asking for a total number of penguins. And so we actually need the part to total, okay? So we need the part to whole relationship between penguins and lions. And so that means that there are 13 penguins for 14 penguins and lions total. Okay, so let's call that T for total. Okay, so it's 13 penguins for 14 total. So now we actually are going to use this ratio to set up our proportion. Again, we're trying to solve for total, so we want total to be on top. Total of penguins and lions over the number of penguins. Our ratio is 14 of the penguins and the lions over 13 penguins. We don't know how many total animals there are, but we do know that there are 78 penguins, and we can go ahead and multiply by our least common denominator, which again is going to be 78. And so it's going to cancel on the right. And then 78 divided by 13 gives us 6. So this becomes 6 times 14 equals x, which means we have 84 lions and penguins.